Let's just wait for a couple more people to stream in. But today our topics are going to be very much assignment focused. We've got two, maybe three main things we're covering today. Number one is going to be testing your code and debugging your code. If you guys know Thonny, you could do line by line, checking what your code is doing. You can do that in Java too. We're going to show you how. The next thing we're going to show is how the testers work. So on your Ed and on your my courses, you'll see we have these tester files that look intimidating and scary. We're going to learn to use those tester files and to, well, make sense of them. Next thing we need is also a little bit of inheritance and OOP stuff that we'll just touch on briefly, because the kind of tester and debugger stuff, I think, is a bit more important. But before we get started with any of that, we've got a bit of assignment setup knowledge to get through. So when you're setting up your assignment, you know that it's on Ed, right? But you also have it on my courses. So if I go to like the Comp 250 assignment page here, you'll notice that we have our PDF here, right? Typical stuff. You also have your Ed assignment submission page where you have all your files, right? This is all stuff we've probably seen if we've started the assignment. On Ed, if we go to whatever tab it is what the assignment is on, assignment 1, right? You'll have it here as well. But pretty importantly, you've got something called the tester here. Now, this is probably the most important file you can download because it's going to let you test your code the same way that Ed does and do so in your own IDE. So you'll be able to actually see your code running line by line and fix your problems much more effectively than Ed, because Ed does not tell you what's going wrong. It basically just tells you you're done messed up, but it doesn't tell you why. This tester will tell you exactly why you've messed up, and you'll be able to use it. But to show a kind of similar version of a tester, we can test our code from previous tutorials. So what I've done here is I've kind of made a similar tester and dragged it into my IntelliJ. Now, this tester file, all you do is you click download, you drag that into your SRC folder for your assignment, right? It'll show up. But when it does show up, it will probably show up with a ton of red errors. Specifically, it's going to show up probably like this, where you've got red errors for things like JUnit here and red underlines for display name and tag. A lot of red going on here, right? We don't like this. It's not a problem with your code. It's a problem with just the setup, and it's really easy to fix. So if you guys have these red errors here, like this, what you have to do is you have to go to the top of the file here where it says JUnit, hover over that, and click Add JUnit for the class path. It's just the first thing that comes up in your suggestions. You click that, you press OK. It's going to download. You do the same thing with this word Jupyter as well. You click Add to class path, press OK. And now all these errors should go away, and your code should be able to run. If one of these things is red, like if one of the classes that you need to have is red, that's just because you haven't written it yet. You just have to write all the files as they're described. And then the tester should be able to run. And you'll have these play buttons here, which we'll get into a bit as well in today's session. But this is the main idea, right? This is the tester. You've got to download the tester, put it in your source folder. Then you've got to hover over these guys, install them. And then you've got a test class ready to go. So this might look different than your typical code because there's one weird thing about it. Now, usually in Java, what do we need to make code runnable? Like, what needs to be there if we can run our code? Main method, right? We don't see a main method here, do we? We don't, right? But we still have a play button here, right? So we can still run this without a main method. This is a special type of code called a unit test, where the rules are a little bit different. Usually for a standard Java program, you have to run it from the main method. But because this is a test file, and it has this special tag at test at the top, it actually runs each method that has an at test can be run on its own. So we can click run here next to this test, and it'll actually run that test for us. And it will actually check that the test passed, and it'll give you a little check mark here, right? So it'll run all these individual tests. If you've got a file with a lot of tests, you can click this button at the top of the class, and it'll run all the tests in that class. Yeah?
So if you wanted to run just one test, you don't think you've done the whole thing.
You have to have, so you have to avoid compiler errors. That's right. If there's a single compiler error, nothing will even run. You have to implement all your files. So for the mini tester, for our Comp 250 mini tester here, I think I've downloaded it here actually. Tester copy.java. Yeah. So this guy, right, it's got a ton of tests, and they all test every single class and every single method. So my suggestion to you guys would be to write out the headers and everything, just write out like blanks for every single method and every single class. And that way your test will be able to run. And on Ed, if you try to submit and you don't have every file implemented, it will just error out and it won't tell you why. So unfortunately, because of how Java works, we need to implement everything all at once. It's kind of like an interconnected web of all different files that all talk to each other. So if one of them is missing, the whole thing kind of falls apart. Yeah.
In the tester file, like not just JUnit and Jupyter were read, but like other things too.
Yeah, that's normal. So if things like @test are read, or any of these @symbols or the assert keyword is read, that's because of JUnit and Jupyter. You just have to fix it by hovering over the import at the top of the file here. Hover over JUnit and click add to class path. That will fix all the red, except if you have like missing files. So if you don't have hotel reservation.java or something, that won't fix it. Yeah. Yeah, they should be identical, yes. But there's no hidden test on the My Courses one though. But yeah, yeah.
The assignment says that we should start testing our code after the entire done. So like how do we like break it besides press the testing?
Yeah, that's a really great question. And it's something that maybe should have been more clearly communicated in the design of the tester. But what the expectation is that as you write your code, you kind of like print stuff off and try things out as you write it. So let's say I write a method that's like, I don't know, reserve hotel, something like that, right? I could then make a main method and try using it a little bit and just make sure it kind of works. And yeah, you don't have to make it formal. You don't have to do anything fancy because the mini tester does that for you. But the point of that is that if you eventually write everything and the mini tester fails, it's hard to find where the error is, right? Because you don't know where to look. So it becomes a bit easier if you do it piece by piece. And you guys all who started writing the tester and got errors about the files not being there had the right intuition about it. It's just, you know, maybe the tester in Java is not as good as it could be because it requires all the files to be there. Yeah. Well, there's lots of reasons that could happen. One of those is that it could be that if you modify the tester from My Courses to, let's say, change the name of the package or something, then it would likely pass on your computer and fail on Ed. The other possibility is that Ed also has hidden tests, which you don't see on, when you submit. But the tester you download is all of the exposed tests. So here you could literally read the code of every test. You know, if you're curious why you're failing something, you can literally see exactly what the test is doing and figure out the situations. Ed has some extra spicy tests that are just evil that you don't see the code for because they will do random crap with your code that you don't expect. And the reason we have those is that they're like unforeseen circumstances. You know, like here, these tests are all pretty straightforward. Like is basically what the PDF says. The ones on Ed are like spicier versions and you don't see exactly what the code is. So you kind of have to do some detective work and figure out why. Not necessarily more work than the PDF, but there might be implications that the PDF has that are not tested in the tester that's on My Courses. So My Courses might literally test, do you have a file called this? Does it have the method that has this name? And, try using the method in the most basic way possible. But on the hidden tests, they might do weirder stuff. Like they try to set random things to null, or they like try to mess up your code as much as they can. They basically are very, very lawful evil. They'll like do everything according to the PDF, but come up with the most evil possible combination of things from the PDF that they can think of, That's kind of their job. Yeah. That's something we'll get into a lot today, because our main topic today will actually be fixing problems in the tester. And that's through something called the debugger, which is something you'll be familiar with if you've ever used Thani before, because it's kind of the same thing, but a bit more powerful. So that's kind of what we'll be talking about for most of today. But before we get into that, are there any more questions about the whole JUnit thing? All right, well, if that's good on the JUnit thing, then I think we could start getting into our, why did I minimize that? That was so silly of me. Come back, mouse, come back. Okay. Where's my mouse? I'm dying here. No, my mouse should be here. Okay, cool. Not cool. Why is the mouse going to the iPad? I'm dying right now. I'm actually dying. I hate this so much. The mouse is now stuck on the iPad. Oh, wait, no, it was back for a sec. Okay, now it's on the other screen. Oh, is it back? It's back! Okay, cool. Yeah, sorry, my mouse just kind of likes to hide sometimes. So, now we gotta put it back on there. There, now it is, okay. Finally. So today, we've got a bit of an example case, right? So we've got our code from last time, which was, well, I think actually in your guys' time it wasn't called bunny job. We had like a job class, but since we had Natalie on Friday, we had to make it bunny related. But yeah, so this bunny job class, right? We wrote this. The basic idea of it is that it has a bunch of fields like the pay, the name, and it has some rules that the name cannot be null. So if you set the name to null, it gives you an error, right? It's a pretty simple class. We talked about it last time. But now we want to have a tester for this class. Last time we can imagine we were like writing the assignment. This time you can imagine we are doing the testing and the debugging and trying to see if we actually get a good grade. And the way we do that is we download our tester just like we did. We imagine we downloaded this from my courses and we got this tester, right? We can run the tests like this and we'll pass them, we'll fail them. Here we pass all the tests. But we could add a spicier test. Let's say that there's an extra feature that you cannot set the name of your bunny to a swear word. So let's add that other test here. I'll just copy paste this. You won't have to add your own tests like this. I'm just doing it for the example. But let's say here, the name of our bunny, let's set it to, I don't know, what can we set it to? Darn. Now we don't want the bunny to be set that, so we could like assert not equals, well, which also you don't need to know about. It's just like me updating the test. So we want the name not to equal darn after we set it because we want it to fail to set this name, right? So to be able to do this, we'll make this test. Now if we run the test, it fails right now. And it's failing probably because we're not preventing the name from being darn, right? So it's saying that expected, not equal, but was darn. So nothing stopped us from naming our bunny this way, even though this is an egregious and horrible name that nobody wants to see. So what we can do is we can use something called the debugger to figure out what's going wrong. Now this might be a kind of obvious problem, right? It's not too much code going on, but we want to use a simple example to show off how the debugger works. Basic concept of the debugger is this. You've got, this is a bit small on the text, unfortunately. But you've got a couple of main areas where you could use it. And it relies on a concept called breakpoints. So here, you can click next to a line number, any line number, and it puts a red dot on that line number. What that does is it tells your program to freeze when it gets to that line and to show you the values of all your different variables. It freezes before the line executes, that's right. So it stops as soon as it gets there. And it's a bit different from Thonny because Thonny lets you run line by line from the top. But as we know in Java, code doesn't run top to bottom necessarily. It just runs kind of from wherever. So we need to tell it where to pause our code. So here it pauses when we get to this line number. Once it pauses, we have the next thing, which is step controls. So here in the blue, and we'll do an example of this. I'm just kind of showing what we're talking about here. These are what's called step controls. This button right here is the most important one. It goes to the next line. So every time you click it, the line that it's on, that the breakpoint was on, that was paused, executes, and it skips to the next line, goes to the next line. By repeatedly clicking this button, we can run through our code line by line and see what it's doing at every step. There's a couple more. Step into, what it'll do is if you call a method on a given line, it actually enters that method and starts at the top of that method and goes line by line inside. So if you're calling a method and you want to see what's going on in that method, you click this down arrow. The red down arrow is similar, but the red down arrow will let you go into any method, including like whatever methods are provided to you by libraries or methods that don't want you to go into them. The red one forces it, so no matter what it's running, it's going to go into the method. The blue one is similar, but it steps out of a method. So if you figure out the method is good and you don't care anymore, you want to go to the next line, you click the blue up arrow. And then this one's pretty fun, the run to cursor. You can put your cursor on a certain line and click it, and then it's going to run all the way to that line and stop. But we'll see examples of these. This probably, you don't even memorize this. It's just kind of like an overview of what we can do. And then the next most important part is this purple area, which is your variables view. It shows you what the values of all your variables are everywhere in your program. So in here, you'll have a list of everything you made. So here we have an int x, which is equal to 7. And we're in the context of an object called this, because it's what this points to in your code. And it is something called a cell with a certain memory address. So we can see all our different values here and all the different variables that go on. Yeah?
And if we put a variable that's like a reference to an object, is it going to show the object or the reference?
So initially, it'll show the reference like this. See, it just says the number. But if you click this little triangular button, it expands it down and it shows you all the fields. So you can have both. And it's better than printing for that reason, because with a print statement, you can print it off, but it'll just give you the address. With this, it's interactive. You can actually view every property of the object, yeah?
Are these icons or things specific to a tag?
Yes, this only applies to IntelliJ. Eclipse has a debugger, but it is extremely confusing and hard to use, so probably a bad idea to try. But if you're really hardcore, you could probably use it. But then you'd be much more hardcore than I. Yeah, and then the final and most important button of the entire debugger is this little bug icon. Those breakpoints, those red dots that pause your code, will not work unless you run it with this icon. If you run with the regular play button, it's going to ignore them and run normally. If you run it with the bug icon, it's going to work with the debugger. That's kind of the basic overview. And again, a couple step-by-step guide version of it. And these slides will be posted, so you can have this as a bit of a cheat sheet for using the debugger. Try to make it as cheat sheety as possible for you guys with screenshots and stuff, so you have like a reference to follow along with. The point is, you assign your breakpoints, which is clicking the red dots next to the line numbers. You click the bug icon to run your code. You navigate with the step controls, and then you can view the values of your variables. And here, if you view the value of your variable, you'll also see that next to the variables in your code, it'll show you the values. So it'll kind of let you use your own brain to see what it should be and see if it lines up. That's the basic idea. And it also, the important part also is that it doesn't do compile time errors. It's about runtime. So in compile time, you fix them. You have a red underline, like you do with JUnit. You hover over it with your mouse, and you click fix usually. That's compile time errors, right? Your program won't even run. This is for runtime error. So it's for things like Stack Overflow or failed tests or null pointer exception. The debugger is for problems that come up after your program's already compiled. The linter, which is what the red underlines are called, is what's for compile time errors. So Daniel, why don't I send you to use the debugger and fix whatever's going wrong here?
Okay, let's do it. I found the mouse.
Oh, yeah, you found the mouse much faster than
Yeah.
So if we want to debug
Okay.
straight from this, like if we want to see what's actually going on here in this test, one of my favorite strategies is to actually put a breakpoint straight on the test right itself. So breakpoints don't just have to be in your code. You can also put one on, like, let's say the first line of the test. And what that will do is it'll freeze your program right at the first line of your test. And then we can use those step controls to figure out what's going on and what the test is actually doing. Because sometimes it's not even obvious what the test is testing.
Can I even put a breakpoint here?
I think you can. I think you did.
Oh, there we go.
Did it work?
Come on.
Wait.
It's not letting.
Wait, can I try? Oh, wait, did it? No.
Okay,
Yeah,
there we
no,
go.
okay. Yeah, IntelliJ changed their UI a little bit, by the way, so it looks a little bit different from the screenshots now if you update to the latest one, but the ideas are all the same. So,
Okay, so we're gonna run the debugger.
and that's the bug icon. Okay, and now we can see
Okay.
a lot of overwhelming amounts of detail for some people. But here, a bit of a pop quiz for you guys on the run controls. If we want to see what this bunny job constructor is doing, which of the arrows do we use? Do we use a step over, step into, step out of? Which step control should be used to actually see what's going on in this constructor? Yeah. Step into would be right, but I think, Daniel, I think you probably
Yeah.
have something to say about the this, stuff like that.
Yeah, so, well, in this case, this is gonna be the test itself, right? So right now, it's not related to the bunny job. This is for the test we're doing, because you can see here, the reference is a bunny test, and you can see it has no fields. Because it's just the tester class. Do you have anything to add?
Yeah, no, I think it's good.
Yeah, okay. Okay, so let's step into the method. And now we're into,
Now we're in this class that we wrote in the Friday
Yes.
tutorial that we're probably not too familiar with, but that's okay, because the debugger will help us understand what's going on, even if the code is really complicated. So if you get an internship at some big company, and you're working on their 10,000 line of code Java program, and you haven't memorized the entire thing, the debugger will help you because it'll only run through the parts that your code is actually touching. So it won't, anything that affects you, it'll show you, but things that don't affect you, it just won't show you.
so now we're gonna advance through step over. It's gonna move to the next line.
Looks like it went back to this test, because I think it finished
Yeah.
running with the constructor. The constructor doesn't do much, it just sets all the fields. So
We're
let's
gonna
see.
go into the next line.
Now
Now we have
this-
set name. Now let's see what this one does. Okay, so here we have the conditions we have and the parameters. So it already tells us that the name is Darn. It's gonna check if it's null, and it already tells us this is gonna be false. So it doesn't go into this if statement. Now it's gonna compare it to heck, and it's still false. So it's just gonna set the name. Now, if we could step over, we'll see that it's gonna skip this line because it's false, and it's gonna do the same thing here. Since the condition is false, it's just gonna skip, and it's gonna set the name to darn.
And now an important thing about what you're showing us here as well is that, see, when you hovered over this dot name, like it actually shows you the value of this dot name, right? So here you can actually see the difference. Like if you literally hover over this dot name, it'll show you the value of this, which is a bunny job, and the name field, which is right now is FIFA, right? So when you hover over various variables in your code with the debugger enabled, it'll actually show you what all the values are. And it's also a great way to learn about Java syntax, because if you are not clear on the meaning of this dot or like that kind of stuff, this will explicitly show you. Like we can explicitly see the name as the argument is the name darn. It shows us over here, right? And we can also see explicitly that the this dot name is a different thing. It's this FIFA value. And we can see those two next to each other when we do the assignment. So it shows us in real time the values of all our different variables. But I've got one question for you, Daniel. So the value of this, right, it used to just be the tester class. So why is it now a bunny job? Why has it changed? Why has the value of this actually changed here in the debugger?
Yeah, because right now we're inside the bunny job class. So this is gonna be referring to the actual job that we're trying to name. So if we look at it here, it's gonna give us a reference to the bunny job, and we can see all the fields and all their values. So when I see this dot name, it says FIFA, and here we have all the other parameters, well, the variables inside of the class. So you see everything in here, instead of having to print every single one and trying to figure out what went wrong, you can just keep a track of all of them. And we can see here the name, which is this, and then this dot name, which is FIFA. So
another cool thing about this is that we see here that the names, I don't know if it's too small for you guys to see, unfortunately we can't zoom in on the debugger part, but our strings are all arrays of numbers, and if you know how your char type works and how the character is actually just a number, which represents a certain letter, like which part of your keyboard the letter is on basically, you'll see that each string is actually a bunch of these numbers, which are chars, that represent each letter in the string. It's just an array of those. And those are the kind of details the debugger lets you see much more easily than otherwise. Yeah.
Why are the two names different? Like, are we trying to like reset the name or like change the name from one to the other, or?
Yeah, so right now in this method set name, what we're doing is we have a field called name in bunny job, and we want to change that name into a different name.
Okay.
But our test is telling us that the name darn is prohibited. We can't give it the name darn because it will, it's too inappropriate. Our bunny can't be called that.
okay, so now that the method is done and we've updated the name to darn, we can just step over, and we'll step over again. We're gonna leave the method, and I'm just gonna run this test. Do I get into this test, or do I just?
I don't think you can get into the test code, but what we can see though is that this has a little bit of a yellow dotted underline around assert not equals. What that means is that we failed this test, right? So this test is saying that these things have to not be equal, the name of the bunny and the word darn. Right? So for that reason, we're failing the test. Now, there's several ways you can address this problem, right? Since our rule that our test is telling us is that darn is not an allowed word. So let's say that the way we're supposed to fix this is we're supposed to change darn to D star star star. So then how would we implement that? Like if we get the input darn to our setter and we have to change it to like D star star star. Right. How would we be able to change that? What do we have to modify in our code? Did the debugger show us where we have to make that change? Right. So if you remember with the debugger, when we were running it, it took us to a certain method which had a bunch of these if statements. Like if it equals null, we kind of saw it in one of these methods. I think it was set name, right? So we had these if statements. So could we add another if statement here for darn as well? Right?
Anyone put stars instead?
Yeah, let's put stars on there. Well, let's see if it fixes it.
It's not fixing it. I don't know why.
Well,
Name equals darn,
well, we
that's
can
not
use the
thing.
debugger
Yeah,
to figure out why it doesn't
right.
fix it. So if
Yeah,
you're not
let's try
sure,
and-
right, about anything in Java, pretty much any problem you might ever run into, debugger pretty much always works because it'll literally run your code as you watch it and help you see what it's doing. You don't have to think about it too much.
Okay, let's run it again with the debugger. Okay, we're gonna go to the set name, step into it. First condition is false, second condition is false, we're gonna skip them. Third one is true. Now, this is the current name, and we're trying to put D triple stars in it. And we can see here, if we hover over this dot name, it changed it to D triple stars. And if you go back now, step over, we can
See, the name actually got set to darn. Because I
yeah,
think the
let's-
last
let's
line
go
of
to
that
the bunny
code,
job. You can see the name here.
it's darn, right? And I think the reason for that is at the end of the set name, we don't have an else statement, right? So it just changes the name back to what we set it to. And we could see that while it was running, because we could literally see the name did successfully change, then it got changed back to the wrong one. So what would you have to do to modify that? How could we fix this problem? Yeah?
No, actually, it's a question. I don't understand what you just said.
Okay,
Why
so
did it change back?
yeah, we can try rerunning with the debugger again and try seeing, like, watching it happen again. Because it's probably better to do that than to, like, try going through it manually. So if we go into set name here and we analyze what it's doing, right? Will it go in, do we know, will it go into this statement here on line 20? No, right? Will it go into the statement on line 23? No, right? Because it says equals false. Now, is it going to go into the statement on 27? Yeah, because it's true. Let's see it. So it looks like it will go in. It did change the name successfully after we run this line to the D star star star. But what line is it going to go to next? Right? It's going to go to line 29. Now the debugger is telling us on line 29 that this dot name, which was just changed to D star star star, will be replaced with name from the input. Now if we scroll up to the input area of the method, we can hover over name and see the name is still darn. Like the input name is still darn. It's not D star 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 because we changed this dot name. Right? So if we scroll down and we see, what we're doing is we're replacing D star 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 with our original input, which is what's causing our problem. So what would we have to change about our code so that this last line here doesn't run when it's not supposed to? Yeah.
Would it make sense to just write this dot name equals this dot name, or is that?
I guess, but what about when we have other cases? So if we do that, we can try. Let's try changing this dot name equals this dot name. We'll see if we pass all of our tests. This is kind of where the mini tester comes in handy. So if we go back to our tester file and we rerun all the tests, if we scroll up to the top, we can see there's a button next to the class where it lets us run all the tests in the class. Let's see what happens. Looks like it's now passing. You can reload on that. It's now passing the first or the second test about the darn, right? Because it's setting it to D star star star. But it's failing the first test, which was just testing setting a regular name without a swear word in it, right? So this kind of testing thing, the tests all test the same thing, so changing one to fix it might break the other one. But now we could repeat the same kind of debugger steps with this other test and see what we can do to make it pass.
Okay. Okay, let's go back to set name. First condition is false because you have a name in the input. It's not equals to heck, so we're gonna skip this. It's not equals to darn. So we're gonna assign this dot name to this dot name. But since the pet doesn't have an initial name, it's already null. So now it's gonna set it to null again. So basically what this does is it's not gonna change the name. It's just gonna set it to null. And this is the bug. So basically if we continue now, if we leave this method, you notice here for the bunny job that the name is null.
So we need this line to run, the last line, which says this dot name equals name, but we only need it to run if the name wasn't darn, right?
Okay, so we can fix this using two different ways. First way, we can just do an else here. This will fix it. We could also do an empty return here. And obviously it's in gray because we have this, because it's not needed. But you can either do this, return, nothing, because it's a void method, or you can do else, this is our name equals name. What this is going to do now is, if the name is darn, it's going to set it to d3 stars and stop the method. Or if we don't have this line, it's going to go into this else, if the name is appropriate, and update it correctly.
What does that empty return do?
It just stops the method. You know how, like, when you have if statements in a method that returns a number, for example, if something return 1 or return 2, you can do the same thing here to end the method early. But usually for like assignments, we'll tell you to throw an exception. This way we know that you did your job properly. Like, oh, you know this is not allowed.
Yeah, we're not showing that in this one just because I was too lazy to write the code to test that because it's a bit more complicated to test. Yes.
If there was like a list of, or like the assignment said like, make sure it doesn't include any of like this list of like 10 swear words or something, like you can't, like, I guess it'd be inefficient to use a bunch of if statements.
You could loop through the list of swear words and check if it's
Right.
equal to each one.
Okay.
So that would work, but if it doesn't really affect the debugger code of it, right? Like you'd probably do a for loop and check each one.
Anything else?
I think that's pretty good on that. Let's see if our test passed though.
Yeah, let's see.
Looks like we passed both. So this is kind of what we want to do. The one more thing we want to talk about is the fact that on ed, you're probably going to have more difficult testers. So the mini tester will probably be something like this. You know, we test the basics. We test, does it work with a correct name? Does it work with a swear word? But on ed, they might have additional tests where they try to mess up your bunny as much as possible, like set random things to null or like kind of do the maximally evil thing they can do within the rules of the assignment and see if your code still works. So even if these tests pass and something fails on ed, it's probably because they came up with some kind of an evil situation. So what I like to do about that is that I like to create my own tests where I just try to think of like what input is most likely to break this code. Like what is the input I least want to see be given to this program? That's probably what they're going to do on the hidden tests and what you're going to probably lose a bit of marks on, but I think you'll also see if you're passing the hidden tests when you submit. So no anxiety there. You'll at least know how you're doing on the assignment over time. But yeah, so besides that, the other thing we want to talk about today is inheritance and OOP a little bit. But before we do that, are there any questions about debugger and testing stuff? Yeah?
Is like, there's like the mini tester, and then in ed when you like submit it, or like when you like run it in the ed submission box, is that like another tester, and then there's also another thing, like are there 3 testers, or like?
So there's essentially 2 testers. There is the tester on ed and the mini tester. Now the mini tester is a subset of the one on ed. So ed has, let's say, 10 tests. I don't know the actual number, but let's say ed has 10 tests. Then the one we give you on my courses will be 5 of those tests. The reason for that is that the ones that we give you on my courses, you can do the debugger stuff with, and you can figure out exactly what's happening. But technically, because that gives you so much knowledge about what the test is doing, you could easily also just hard code every possible input and then return the correct output. Basically, like, you know, if the input is this, return this, and pass everything very trivially. So to prevent people from doing that, we also have hidden tests on ed, which just expand up on top of the ones that we post on my courses.
And so will we not know how our code does on that one until like, we get assignment back?
I'm not clear on that. I think this semester you will know right away. So whatever grade you get on ed will be your assignment grade. So if you get 100 on ed, you're good. You can stop. But not sure on that. You'll have to ask Julia or some of the tester team for that. Yeah. Is there anything else on this? Yeah.
If you put the tester into IntelliJ and you can't run it and you don't see any of the green things, what does like the green triangles display it?
Yeah, did you hover over the word JUnit here at the top under imports and click add to class path and Jupyter as well?
Like so you have like the
Okay, so those ones are there. Okay. And
there's like no red squiggles.
did you put it in your SRC folder?
Yes.
Wait, can I see that for a sec? Looks funny to me.
Okay, maybe I didn't do it wrong.
Oh yeah, it's because it's still called tester-copy. So, and I don't see it in there. So it looks to me like it's possibly not in the right place / with the wrong file name. It's a bit silly that we call it tester-copy, but that was, this makes me worried about that in the first tutorial, but I think it's still under downloads right now. I'm not sure though, because it's not in the SRC folder. Oh, okay, so that's still in downloads then. So what we gotta do is we gotta take this out of downloads, then we gotta rename it to tester.java, and we gotta put it into our SRC folder. So we're gonna take it here, drag it into IntelliJ, whichever one it is. Yeah. So we drag this into here, into SRC.
No, I was just like Thailand,
Right.
just like.
And liquid refactor, and then you have to rename it from tester-copy
Cause like I
to
just
tester.
found test cases.
So that's the next step.
Yeah.
Right click, like rename it, and then you have to hover over the JUnit. So those are like the 3 steps. Alrighty, so now that we've kind of talked about JUnit and stuff, we can get into the OOP side of things. So can we get a quick recap from any of you guys of last time when we talked about making your own custom data types? What are the kind of core aspects of that? And what are the core aspects of our custom data types?
This is beautiful.
Oh yes, the demon bunny. Well, yeah, so last time we talked about custom types, right? So we talked about something like we would have a class bunny job, class job. It has certain properties, right? So we can think of that as like a class job, right? And it has whatever properties. So it has something like a job title, a start date. We kind of talked about that last time, right? We remember that we can have a custom object. The way we do that is we have a class of some kind which has fields. So another thing that's very important in 250 and is part of A1 is what's called inheritance and extending a class. So while we might have a class called job, we can also extend that class to something more specific. So maybe we have internship as something that has all the same properties as job, but has some additional properties too. So a regular job has a start date, but if it's like a full-time job, it doesn't really have an end date, right? Like we don't know when it's going to finish. But with an internship, you know that it has a certain start and a certain end date. So if we want to have an internship class, what we could do is we can Control C, Control V, copy the entire job class over, and make another class here called internship, right? Class internship dot dot dot, and this will have all the same properties. You have to copy paste each one over, right? That can take a lot of effort, and then we can't really treat them the same way. So if we want to, let's say, have a for loop over all of our different jobs, and we want to include jobs and internships in that for loop. Let's say we're like making a job board and we want to put all the job postings on the same website with like the same interface. Then we have to be very careful about naming all our variables the same way, right? So here we have to have the exact same name job title. Otherwise, it'll give us like a null pointer exception because there's no such thing if we don't name it the same way. So if instead of job title, we called it something like, job name for internship, suddenly, even though it's supposed to be the same thing, it's actually not the same thing anymore. So how could we structure this in a more efficient way? What would we really want to do when we have this kind of a situation? Sorry? Yeah, so that's where inheritance comes in. Yeah, so you make the job a superclass. And what that means is that the internship will be like an extension of job. It's going to have all the same fields as job, all the same methods as job, but we're also going to tack on whatever extras we want. And that has a couple of cool effects. So one of those effects is that it literally means that an internship is a type of job. So any code that works on job will also work on internship because it already inherits all the same properties. So then what we can do, the way we draw that, if we want to do it like you'll see it on the midterms, we'll draw it like that, and we'll say class internship. Now, what this arrow means is that it takes all the same properties as job. So would it be valid to say internship.job title? Yeah, the answer is yes, because internship will have all the properties from job. Now, if we have a private field here, let's say private, boss name. Now, will we be able to access the boss name field from internship? Would we be able to say internship.bossname? No, that's a bit of a quirk of it. You can't access those. So you have to use the getters and setters. But everything that isn't private just gets carried on over. And internship, right, it gets all the methods of job as well. So if job has a method called hire, internship will also receive that method and it'll be the exact same. If we look at our IntelliJ, very similarly, you'll know that we have some classes in IntelliJ, right? Like when we write a class, we have bunny job. Bunny job doesn't just have the methods that we wrote. Bunny job also has a couple of extra methods. So here we can say bunny job dot hashcode dot toString dot getClass. All of these methods are coming from somewhere, right? What's happening here is that every class that you write actually already inherits from another class called object, which gives you all these basic methods. But if you want to customize how these methods work, that's when you can do something called overriding. And that's something we've seen before possibly. But if we want to change, let's say, how the bunny job is represented as a string, what we can do here is we can say, we copy the same signature. So we'd say public string toString. Right, and that's what's called overriding. We get this little icon in IntelliJ, a little blue circle here. And that's saying that we're replacing a method from the superclass. Now, if we want to, let's say, return the same thing as the superclass would, plus an extra little bit of detail, how could we do that? How could we take the return value from this method from the superclass and use it?
Can you call it in that method?
You can call it, yeah. So there's an extra keyword we learned. We almost learned every keyword now, but there's one more we haven't seen yet. We know this refers to the current object we're in. There's another one called super, which refers to the superclass of the current object we're in. So that says that this bunny job extends object, so super will refer to the object that it extends from. In our internship analogy, it would be super of internship would refer to job. So here we could say return super.toString plus, and then some extra stuff. So here we could just add like whatever funny message we want to add and have that be returned. So now every time we print our bunny job, it's going to print whatever the superclass was, and the print method of object returns like the memory address. So here, if we now, in our tester, let's say, we print off our bunny, and we run it, yeah?
So in the internship class, in the header, we'd have to write extend.
We would, yes, and I'll show that in a little bit as well. But for now, we can see here, the bunny job, it printed what the super printed, which was the memory address, and it tacked on whatever string we put at the end, which was this thing. So we can see we used the method from the superclass, and we added our own content. So that's kind of, yeah.
And then, like, using toString, is that just, like, do you have to do that all the time when you're using
So toString, what it does is it lets you print an object. So whenever you print something to the terminal and you do system.println of an object, it actually calls the toString method. But most of the time, you don't have a toString method implemented. So what it's going to do is it's going to call it from the superclass, which is object. So yeah, so that's kind of one of the main properties of object-oriented programming is this extension. Yeah.
So super goes to the highest class and
Super goes to the next class up that has that property. So if we say super.toString, it'll go to object. But if you have another class in between, so if you've got object and then you've got job, which has its own toString, and then you're in internship, it'll do the one that's next one up. So it'll do job if you're in internship.
not object.
Yeah, it'll do just whatever is like this the direct parent, the next direct parent that has that method. So this is kind of the core idea of it. Your properties kind of cascade down your classes. So whatever comes with a job goes to internship. Then you can keep extending it, and we can see a bit of examples of this. So let's say we have bunny job. I want to send you, Daniel, to make a bunny internship class, and we can do a bit of trickery with that.
Okay, so we're gonna call this a bunny internship. No typos. A lot of typos. Okay, there it works. Okay. So we have our class. Now the first thing we're gonna do.
I think you've actually made an interface there by accident.
Okay. Okay.
Zoom that in.
That's way better. Okay, so the first thing we're gonna do is gonna establish the parent-child relationship by doing extends bunny job. Now see, there's gonna be a red line here. It says there's no default constructor available in this class. So what we're gonna do is we're gonna make one that matches the parent class.
So that was kind of a lot of stuff all at once. Right?
Yeah.
So if we remember from last time, when we were trying to like defend our code from the null, we created a constructor that like forces us to fill out all of the things we need to create that object, right? But when we create a subclass, when we create the internship, we also need to create the job object that it inherits from. So all of the same rules still apply. We still have to use that constructor that we made last time to actually create the object. So that's what IntelliJ did for us here automatically.
And you don't need types. Right? When you're saying super here, and then you don't need like super int.
Yes. So basically, when you call super, it's gonna call the constructor in the bunny job class, which if you go over and look at it, it's gonna be this one. So when you do super and give it the same variables, it's gonna do this because we just did super without any methods, which is basically the constructor of the parent class. Yes.
If there was only the default constructor being used in the super class, like then would the subclass inherit just the default constructor, or?
Yes. Basically, if the parent class has a constructor, the child class has to have the same one too.
Okay.
So if there's a default one, this one's gonna have the default one too.
Okay.
Now you can add more constructors here, but you need to have the basic one that comes from the parent class.
The super being the shortcut.
Super is gonna call the constructor of the other class, the parent class. So in this case, it's gonna call this in bunny job. So basically, once you do bunny job equals new bunny internship, is gonna call the constructor of bunny job because it's the parent class, and we use super here. You can obviously change the behavior in this method, so it can be unique to the internship. Okay, now we can add fields here, such as let's say a boss name, for example. Right? And we can set it here to whatever. We can say boss name equals Sasha, for example. Right? Now this is gonna call the constructor of the parent class, but it's gonna still update this variable and give it the value Sasha. Let's make this private. There we go. What else do we have here? String get name, set name. Okay, so all these methods here that are in the parent class, bunny job, to string, get name, set name, these are going to be accessible from the child class. So even though we don't have them written here, we can call them on an object of type bunny internship because we already have them implemented here. And since it doesn't have the implementation here, it's going to go out on the parent class.
Yeah, when we have our quizzes, or I guess our midterms now on this thing, a really, really common question would be basically an is this valid type of question. So if we have a main method here, and I promise you guys, it'll be on the midterm. If we have something like, let's say bunny job J equals new bunny internship, is that valid? Is that going to be a valid thing to do? If here, instead of making a bunny job, we make a bunny internship, will this be legit? Getting some nods yes. What do you think, Dan? Some yes, some no.
Okay, let's see. Moment of truth. Well, let's
Well,
pass
we got to
on
give it the
parameter.
input. Wait. I think it's going to be int string.
Yes. And there's no errors.
And the logic behind this is that whatever type is on the left, so bunny job, has to be more vague than the type on the right. So whatever goes before the equal sign has to be more general. An example of this is that, actually I'll make it another question. If here we have object, which is the most general possible one, object O equals, what would be allowed on after the equal sign here? Anything, right? Is there any exception? Is there anything that wouldn't be allowed after that equal sign? Something that's not an object. So what could be not an object? That's exactly right. So any primitive here would be invalid, but any reference type is valid. So here we could put string, bunny, job, whatever, but we can't just put like 8 as a primitive, except this doesn't give us an error. So what's going on here?
It's runtime edit. Or
Yeah.
it takes a reference.
So this is one of those things that's very tricky, that's almost certainly going to lose people marks, and it's something that's not obvious. So in Java, when you have a reference type like object and you assign it to a primitive, it implicitly wraps it in an object. So you know you have the capital I integer class and the lowercase I int. So if you put an int and you try to treat it as an object, it'll automatically be what's called boxed and put into a capital I integer and made into a reference type. So that's kind of an implicit behavior that, I mean, there's no reason it should do that. It's literally just how they design Java, and it's kind of weird. But for this behavior, you're totally right. A primitive would not fit as object. But because Java implicitly boxes your primitive into an object, it'll still work.
Is the bunny the line 11 an example of downcasting?
It's not downcasting, because downcasting is the opposite of what we did. Right now, we have a more general type containing a more specific type. So bunny job J, I mean, it's true, it is a bunny job, but it's not as specific as it could be, because we could also say bunny internship. What we would have to do is, if we want to increase how specific it is later, we'd have to do something called downcasting, which is saying like, hey, we need to be more specific about this. It isn't just a bunny job, it's a bunny internship. And that way we have to cast it, which is dangerous, because if it isn't a bunny internship, it's going to break. Yeah?
And so if the question was, is this valid, and it's the object equals the primitive integer 8, like, is it valid?
Technically, yes, because of what Java does to make it valid. This is kind of one of those tricky questions that they would give you if they want to destroy your GPA, but they do want to destroy your GPA, and they will totally give you this question just to make your Valentine's Day that much more romantic. It'll be glorious. But this thing is, yeah, are there any other tough ones, Daniel? You remember what you got destroyed on the midterm? You can give them some more examples. But yeah.
So you said that it turns the primitive type 8 into a reference type?
Yeah, it's called boxing. What's happening is that there's a reference type called integer, and there's a primitive called int. And implicitly, it's going to change your int into the reference type integer because it's being assigned to an object. Now, I don't like this. Most people who use Java probably don't like this either, but it's just how they made it. It's one of those things that just makes Java that much more annoying, but we gotta live with it. Yeah.
Why not? Does it make it easier when you want to work on a primitive type?
Could make it easier, I suppose, but I guess it's like that kind of unclearness of the code that I don't like about it, because by any reasonable understanding of how it should work, this shouldn't be valid. But then because there's some weird internal stuff going on, it becomes valid by something that's not intuitive. Yeah?
What's the point of like making the label a different type than the object that it's referencing? Like you've got bunny job and then it's actually referencing something of a different type.
This is a bit more of a design question. I think, Daniel, could you come up with an example where we would
Yes.
want to take both?
Say we go into the grocery store, right? We have a basket. We can put fruit in this basket, right? Now, fruit could be a superclass, and we can have different types of fruit, such as apple, banana, orange. Now, if you have to make an array, it's going to have to fit fruit in it, right? But if we design it to have fruit in it, then all the subclasses of fruit can be added into that array. So if you have an array of fruit, we can add apples, bananas, oranges, and any other type of fruit into that basket.
This is my
Just like-
favorite
yeah.
example, Minecraft. If you guys play Minecraft, you know you've got your like inventory there, right? It's got all those slots in it for different items, and different slots have different rules. So this slot here, if you haven't played Minecraft, it's only for your helmet. So you have in Minecraft, you kind of like get a bunch of resources and you build stuff with it. One of those things you can build is like a helmet, right? You take a bunch of iron and you put it together to make an iron helmet. Now, the iron helmet, it can go exactly in this slot or any of these blank slots, but you can't wear it as a shoe. So this is a perfect example of Java polymorphism, which is what we have, what is called when you use a more general object type. So here, we would have a class like item, and all of these slots would be for class item, right? Because they would allow any kind of item to fit inside. But these ones would not be class item. They would be a subclass. Like this one would be class shoes, this one would be class pants, this one would be class chest plate. So all of them will have a more specific type. which allows like a really awesome thing where if you take this chest plate, right, you want to remove it, you can put it in your inventory to any of these slots because they'll accept any kind of item. But you can't just put any item and put it up there. Kind of makes sense if you guys have played Minecraft. It's literally using this, by the way. Minecraft is written in Java and it actually just uses this thing directly. So it's a very clear example because that is actually what it is. But yeah, if we want to kind of create this in Java, the way we would do it, right, is we'd have an item class, and this is how we draw the extending, right? So we'd have a class item. We'd have all these different classes. Extending item. And that's what those arrows mean. You'll see those on your midterm. When we have a bunch of little classes that extend a different one, they all have little arrows going to the one they extend. And the inventory would have like an array of items of inventory slots, an array of slots that are on like the hotbar, if you're familiar with that. And then your pants, your helmet, your chest plate, your shield, your boots. All of those would be different subclasses, which would kind of define how the inventory behaves. Because you can imagine if everything was just item, we'd have to have a lot of if statements to check. Like, is this item part of our list of chest plates? Is it part of our list of pants? And it would be a bit complicated. Whereas with this glorious setup, we're able to very easily model that without too much effort. Like Java will just make it happen in the compiler. Yeah, are there any questions about that whole inheritance thing? Yeah.
I guess I'm also wondering if you have something like was written in IntelliJ where it's like, I don't know, like item I,
Yeah.
and then you have like new boots, like input.
Yeah.
Is like what is the like is the object I and I like why would you use the boots thing I guess? Or like yeah.
Because what's after the equal sign is what it contains, right?
Yeah.
So if you want, let's say, like this inventory slot here to contain your boots, you would have to use the boots constructor because otherwise you wouldn't make a boots. You would make something else. So that way, it would still be boots because you still want it to work when you put it in here. But you might want to store it in a more general slot. And then the problem comes of what's called downcasting when you're trying to take those boots and actually put them in a boots slot. Because if it's not a boots, if you try to put those boots in a pants slot, you have to downcast it to pants. And that's where you get something called a class cast exception. So if you want it to be in a more general slot, you can. When you go to put it in the more specific slot, it needs to be the right class to fit in. If it isn't the right class, it's going to break. So that's why you'd use the boots constructor. It's because it needs to be the correct class for the slot you're going to put it in later, not necessarily right now.
Okay, so it can so without downcasting you can put it in the boots thing if it's item I equals boots. Well,
Yeah, if you know that it's going to be boots.
right.
But you can't be sure, right? So what you do is there's actually a solution for that in Java. And that solution is called instance of. So you can say if j instance of bunny internship. So if it's an instance of the more specific class, then you can say bunny internship it equals, and then here you put the class you want it to be. So here I want it to become a bunny internship j. So this is how you can force it into a more specific type. You first have to check if it is the more specific type using the instance of check. And only if that check passes, then you can actually make it happen. An instance of, it actually checks down the type. So if you have like a lot of types, they can kind of look like a tree. Like, you have one type and then a bunch more coming down. Instance of checks if it's at the one you're checking or below. So if you check instance of bunny job, it will still pass if it's a bunny internship. It'll say, is it this or any of its subclasses? So if we see that in terms of Minecraft inventory, again, we've got this is how it would look in the class. You would have something like an inventory class. It would have your item class, and then you'd have something like helmet extends item. And then that's what would define how all those different slots work. Any kind of questions about that concept of it? All right. Let's see. Do you have anything to add on that?
I don't think so. Just when we did on IntelliJ, bunny job equals new bunny internship. You can also replace bunny job by bunny internship to be more specific. But then you lose access to the generality we were talking about.
Can you give us an example of one midterm question that absolutely destroyed you last semester that you can prepare people for?
Okay, let's see.
That's related to OOP stuff. I'm pretty sure there must have been a lot of those that destroyed people.
We had a lot of questions about interfaces. I think they're harder than these.
Oh yeah, well, okay, we'll do interfaces next time, but if you can come up with a hard OOP one, you can swipe up with 3 fingers. It'll give you all the different windows.
Let's see. Good question.
Just thinking back to the traumatic memory of that midterm. I'm just getting absolutely destroyed in terms of the grades.
You know, I really think it was the interface, but let's see here. We can do. So let's just have a bunny job equals. Oh, this is gonna be an easy one. New bunny job I wanted. Yes, it's gonna be. Okay, so say I have a bunny job right here. What's gonna happen if we try to convert this into a bunny internship?
Is that what the code is doing?
No, so I'm just making a bunny job called job, and now what do I do if I want to turn this into a bunny internship?
You force it. With the brackets and
That's a possible solution, but it wouldn't work because bunny internship is more specific than a bunny job.
what if the
Oh, actually, I meant the opposite. Yes, that's it. Sorry, my bad here. It's not a bunny job. It's an
Can I make your
internship.
question a tiny bit more spicy?
Spicy.
Yeah.
You
Yeah.
have
So
a spicy
what if,
question?
yeah. What if instead of bunny internship, we had another class here, which was just like bunny internship class, bunny intern 2, and it'll be the exact same thing as bunny internship. Like it'll have the exact same properties, except it'll just have a different name. Now, can you treat the bunny intern 2 as a bunny internship? Are they the same?
no.
Can you cast a bunny internship to a bunny intern 2? If they're identical classes. Yeah? Yeah, they would, but like if you change the what you're doing when you're casting is like a reference comes in two parts, right? It's the address and it also is what lives there. So what lives there right now would be a bunny. Like let's say it's a bunny internship. If we want to say that what lives there is actually a bunny intern 2, would it work? Because all the properties are the same, right? There's no difference between the two classes. So if we just change the label on it, would that actually be successful? But what would break it? Let's see if it works. Let's give it a test. Looks like it's giving us some red. Let's hover over. Let's see what it's saying. Incompatible types cannot cast. So even though they're identical, Java actually cares that there are two different classes here. Now, there isn't really a good way around this, but how about this? Now it works. So this is a bit of a weird behavior, right?
That'd be greater, like
It doesn't work. You can't cast sideways, right? So if you imagine there's like a hierarchy of your classes, can you switch the iPad view on the screen? Like if you click over here. So if there's like a hierarchy of these classes, right? We've got internship and we've got intern 2. Right? You cannot cast sideways. You can't go from IN2 to internship, right? That doesn't work. But you can always cast downwards. So even when it's invalid, even if it's going to break your program, you actually can cast any of these down arrows. Like this is okay, it doesn't matter what you're actually casting. You'll get errors after you try to access something that's not there. So if you have a method here in internship called, I don't know, fire, something like that, right? If you try to call fire on an IN2, it's going to break. But it's still going to allow you to do the cast if your original object was a job. But if your original object was an IN2, you cannot cast this way. The casting always has to go downwards, right? It always has to go down the tree. You can never cast like sideways, and you can cast up, but it's kind of unusual. Yeah?
I didn't see what you did.
So what I did there was, so originally we had this as bunny internship, IN2 equals new bunny internship, and then we try to cast that bunny internship into a bunny intern 2, which is an identical class. And we got this red compile time error that says you can't do that. You can't cast sideways. You can't go from internship to intern 2 because they both extend bunny job. They're both kind of at the same level. But all I did was change this type to object. Object. let's actually see, object. And now it works just fine because it's allowing us to do that cast because we're going from a more general type to a more specific type. Whereas before the types were equally specific, so we couldn't cast between them. Does that kind of make sense? It's like the weirdest edge case I could think of. Yeah.
But in that second line, you have bunny intern 2 is equal to bunny intern 2, not like the intern 1 equal to intern 2.
So we're casting it, right? So this job is originally a bunny internship. And now we're turning it into a bunny intern 2 using the cast operation.
Oh,
Yeah?
Would line 24 correct and 25 be wrong?
Technically, they're all correct here in terms of Java. Like, this will run fine. It becomes incorrect if we put a more specific class here instead of object. Yeah?
If you do like a bunny job is any bunny internship, and all that kind of thing, and then you like what if bunny internship has its own private field, and then later you try to call that field, but because you downcasted it, it doesn't have that value.
You'll get the error later on that way. You'll get it when you try to use the value that isn't there, rather than when it's casting. Because sometimes you can cast and you can kind of unsafely assume that all of the properties have a certain property. Like you can assume that, you know, bunny intern 2 and bunny internship both have the same properties because we copy pasted them. And if you change nothing, it'll technically always work because you have all the same fields. But then if some dumb person comes in and edits your code and then changes bunny intern 2 but doesn't change bunny internship, then you'll have an exception as your program is running that'll break everything. So it's a bad idea to do it, but it's technically valid. But yeah, I think this is probably the kind of question you'll see on the midterm if they're trying to destroy your GPA, which they absolutely are. So you kind of got to be prepared for this kind of thing. Like the really weird edge situations that like most experienced Java people would not actually know off the top of their heads.
There's also interfaces. They're going to be more complicated than this. So it's going to be both these and then the interface, which is basically like inheriting from two classes in a way. So you're
Yeah.
going to have to figure out which methods work if you downcast.
Don't scare them too.
Yeah, we'll see. We'll see. Yeah.
I don't know if interfaces are on midterm 1, are they?
They were last time.
Oh, was midterm 1 the same time last time?
I
Like
don't know.
about the same number of weeks?
We'll
in?
see. We'll see.
We'll see. Okay. So seemingly this is like probably what a midterm question is like, and then Daniel will come in next week and destroy us with some more difficult examples of the next topics. But if there's no questions, I think that can be it for our topics today. And if there are questions, you're welcome to come up and ask.